So let's see another problem in classical mechanics. So a uniform cylinder of radius r is set spinning about its axis with angular velocity omega naught and placed in a corner having a right angle. If the coefficient of friction between the walls and the cylinder is mu, the number of turns completed by the cylinder before it stops is. So according to the question, this is the diagram, imaginative diagram. So what they have given is a uniform cylinder of radius r. So we need to consider cylinder, cylindrical object, and it at a uniform cylinder means uniform distribution of mass, and it is of radius capital R, and it is set spinning about its axis with angular velocity omega naught. So it is the sphere is spinning, it is rotating about its axis, and it is spinning with angular velocity and it angular velocity omega naught, and placed in a corner having a right angle. So this is a corner, so this corner has a right angle, just like a spinning ball is placed at the corner. So we might be having a ball with us. So actually corner means we would be having three sides touching the cylinder. So if we think just a to just we are placing that ball towards the wall like that, in such a manner if we think. So like that if we think, so in that case, so the corner having a right angle they are saying. So this is a corner, so it is having a right angle it is of a right angle form. So as it is spinning in particular about its axis, so it would be spinning like this. So opposition from would be from from this side, this wall and this wall only. So this is spinning, so it is placed in the corner. So there, this wall and this wall, this is floor and this is the wall, so they both opposes. So in the direction of spinning, in that direction, so those wall will would oppose it. So if coefficient of friction between the walls and the cylinder is mu, so the coefficient of frictional coefficient, so this is a rough surface. So the meaning of this is a rough surface, this is also a rough surface, this wall is rough, this wall is also rough. So because of that roughness, friction would come into play, and it is, and the friction is here mu, coefficient of friction is mu. The number of turns completed by the cylinder before it stops. Now what we need to find out is before the how after how many turns the cylinder stops. That means we have taken a spinning cylinder, so it is rotating with some angular velocity omega naught. So it is going on rotating, and suddenly we have placed it at this corner, in a right angle corner. So while placed on that corner, so those corner will definitely oppose the motion of that cylinder because of friction. So after certain time it would stop spinning, it would come to rest. So in the question what it is asked is, so after how many turns, how many turns it goes through before coming to stop, that one we need to find out. That is the question. So first of all we need to consider the free body diagram to solve the problems like this. So this is the cylinder, so it is spinning. So actually here all is reaction force, we would discuss this. So this is the cylinder, it is spinning. So here it is shown, so it is spinning in this direction like this, that means clockwise you can say. According to the diagram, it is spinning in clockwise direction. So weight of this, first of all, weight of the cylinder would act from the center of mass point vertically downwards. So weight acts vertically downwards. Vertically means parallel to this wall, so vertically downwards mg. And because of contact, so as this cylinder is contact with this surface, so contact force comes, so normal force, so normal force, reaction force comes into play, so in the upward direction. So that is a contact force. If there is no contact, then we would not have this normal force. No, this normal force is a contact force. It acts between if the objects are having contact then only. So here we would be having one of the contact force that is in this direction opposite to this. So as a action reaction like that. And next thing is this is also a contact. Of course, so this is also a contact. So because of that contact reaction force acts in this direction. So this is the reaction force supplied by this wall. So this is also a point of contact, this is also a point of contact. So at this point of contact the reaction force is N. So at this point of contact the reaction force is R, and it is in opposite direction. So reaction force in this opposite direction to this wall. So this sphere touches this, so reaction force would be like this in this direction. Here also contact force is in upper direction like that, normal to the wall. And next thing is this is spinning in this direction. So at this point the point on the cylinder is moving in this direction. So here it would be moving in downward direction. So frictional force would be in upper direction supplied by this wall. And at this point it would be moving like this. So in left hand side direction at this point the sphere would be moving in left hand side. So frictional force would be acting opposite direction, that is right hand side. So this is F2. So this is F1 and this is F2. These are all the frictional force. Frictional force always acts in opposite direction to the direction of motion of the body. So this is the overall free body diagram of the cylinder. So now after this what are all the forces acting on it, after seeing this now we can derive the required thing. So writing the equation of motion. So from the diagram if we see, so here in upward direction N and F1 forces are acting, and in the downward direction mg is acting. So for the cylinder to be in equilibrium position the forces in the vertical direction must be balanced. So that cylinder must remain there in that corner only, and finally it must stop spinning. So upward forces is also downward force. So upward force is N plus F1 and downward force is mg. Now if we consider horizontal, in the horizontal direction, and here on the left hand side R is the reaction force is acting supplied by this wall, and F2 is acting in this direction on the right hand side. So left hand side forces must be equal to right hand side forces. So along the horizontal if we consider, so R is equals to F2. So these are the equation of motion. Now taking moments about the center. So taking moments about the center, that means torque if we consider about the center. So overall here if we see, torque is nothing but R cross F, that is RF sin theta, and it would be maximum when theta is also 90 degrees. So here R is nothing but radius of the sphere. So already here we have considered taken this as reaction force R, and again if we take radius or as capital R we would get confusion. So here they have taken small r as the radius of the sphere. So R and F, and here also R F, R force into perpendicular distance, that means if R and F are perpendicular, so this is R and this is F2, so they both are perpendicular. Here also R is in this direction, F is this, so perpendicular. So moment of force R cross F, R into F1 plus F2. So here F2 and here F1. So R is same for them both. So overall these two forces are acting. So R cross F is equals to I alpha. So these are the forces acting on the cylinder at this point. Overall if you see, so at this point F2, at this point F1. So seems like as if they are rotating that sphere like that, opposing the motion of the sphere. Actually it is opposing in this direction, so they are opposing that direction. So it seems like that. Hence RF or into force acting, so perpendicularly, so or F. And another formula for torque is nothing but I alpha. Just we have formula for force ma, so in the place of mi, in the place of a, alpha. So that is nothing but I naught. So moment of inertia of the sphere, it would be the same, it is a constant. And alpha is nothing but d omega by dt, rate of change of angular velocity. So this is the moment of force, where I naught is moment of inertia of this center. And next thing is, now F1 is equals to mu r. So F1 is nothing but frictional force. We know formula for frictional force is nothing but coefficient of friction into normal force. So actually F is nothing but mu F. So we might have studied formula for frictional force. F is equals to mu n. Mu into normal force. Frictional force. Coefficient of friction into normal force. So this is F1. So at this point, as they have already given in the question, mu is the coefficient of friction between the wall and the cylinder. So for this wall and for this wall, same mu. And here the normal force is R. So mu R, F1 is equals to mu R. And now if we consider F2, this is the point. So F2 is equals to mu into normal force. So mu into N, capital N, coefficient of friction into N, normal force. So that's why we have these two equations based on the formula of frictional forces. So using the above, we can eliminate N and R to find F1 and F2. So by using this, we need to eliminate N and R, and we want to find F1 and F2 forms. So F2 is equals to mu n we are having. So n is nothing but, from this equation we are having, n is equals to mg minus f1. So sending this f1 to that side. So n is equals to mg minus f1. So f2 is nothing but mu into mg minus f1. So that is mu here, mu into mg minus f1, f2. And f1 we are having mu r. F1 we are having mu r. And we already know that r is f2. So f1 is equals to mu f2. So F1 is equals to mu F2. So F1 is equals to mu R we are having, R is nothing but equal to F2. So F1 is equals to mu F2. Sending this mu F2 this side, we are having this equation. And from this equation, sending this mu F1, mu mg minus mu F1 to this side minus, so here it comes with plus mu F1, mu mg. So these are the two equations. Now, so here we have eliminated n and r terms by using those four equations. And now what we have to do is, we need to find out F1. So we need to solve these equations. So here if we see, here minus mu F2 is there. So if we bring here plus mu F2, then we can eliminate F2 and we can find F1. So hence 1 multiplied with mu, this first equation multiplied with mu and added to second equation. So 1 into mu. So mu F, so we would have mu square F1 plus mu F2. So mu into mu F1 is nothing but mu square F1, and plus mu F2 equals mu square mg, and here mu F2. And we already know that mu r F1 is equals to mu r, and r is equals to F2, and F1 is equals to mu F2. So here we are having mu F2, that is nothing but F1. So here when multiplied with mu F2 we would get, mu F2 is nothing but equal to F1. So here this term would become F1, this F2 term, and this is mu this term F1, and mu into mu F1 is mu square F1 and mu square mg. And now what we have to do is just add this, that means we have eliminated F2 term here. So we have replaced F2 with some form of F1. So after multiplication with mu, it has been converted to F1. So this is, in this equation we are having only F1. Now here on the left hand side, if we take F1 as common, F1 into 1 plus mu square. So here F1 taken common 1. So here F1 taken mu square. So 1 plus mu square equals to mu square mg. And that is nothing but F1 is equals to mu square mg by 1 plus mu square. So f1 is mu square mg by 1 plus mu square. And we already know that f2 is equals to f1 by mu. f2 is nothing but f1 by mu. So f1 divided by mu, that is dividing this entire thing by mu, we will get mu mg by 1 plus mu square. So that is the thing, because f2 is equals to, because f1 is nothing but mu f2. So from that we would have, so finally we have found out f1 and f2. And as we have taken moment of force already this equation, so that is this equation, f1 plus f2 into r I naught d omega by dt, taking torque. So this is that equation. Now this equation becomes they are saying, so in the place of f1 mu square mg by 1 plus mu square, and f2 this one we need to replace mu mg by 1 plus mu square. So in the numerator we are having, sorry, denominator we are having 1 plus mu square. So 1 plus mu square is could be taken as common, and here if it is taken as common, mu square plus mu. So mu square plus mu. So actually here we need to add up this both. So 1 plus mu square could be taken as common, and in the numerator what we are having is mu square mg and mu mg. Mg could be taken as common, so mu square plus mu mg, and r is there already. So that is the simplification. And now what we have to do is we have to integrate on both sides. Now we need to send this dt to this side, and I naught d omega here dt. So integrating on both sides, what we will get is this entire thing is a constant, mg, r, radius, mass of the cylinder, acceleration due to gravity, coefficient of friction, entire thing is constant. So integration of dt is nothing but t, 0 to t, that means t, upper limit minus lower limit, t minus 0. So we would have this one multiplied with t, just it. And here on the right hand side integration, we need to consider a simple thing. So integration of d omega from minus omega naught to omega, integration from minus omega naught to omega. So integration of d omega is nothing but omega, integration of just integration of dx is as x. So like that. So upper limit minus lower limit, so omega minus of minus omega naught, so omega plus omega naught we would have. Why minus means so initially this cylinder is moving in this direction, this is the direction of omega naught. So as time passes by, it would slow down, and seems like these forces are making the cylinder to rotate in this manner, anti-clockwise manner. So actually it is rotating in clockwise manner. So actually the cylinder was moving in clockwise manner, but here as time passes by, it comes to stop because of the frictional forces. And in the frictional forces, if you observe, it seems like they are making the cylinder to move in anti-clockwise direction. So that is exactly opposite to omega naught. So they both of final omega and initial omega naught would have differ in their direction. So the cylinder might stop, and because of these forces it might rotate a bit in this manner, like that. So keeping that rotation, that little bit rotation opposing force in consideration, so integration is taken from minus omega naught to omega, because final omega is in opposite is in anti-clockwise direction, and initial omega is in clockwise direction because of that. So I naught into omega minus of minus omega naught, omega plus omega naught we are having. So let the time taken by the cylinder to stop rotating be. So let us suppose after t time the cylinder comes to rest. So that is given here. So capital T, and at that time final velocity of the sphere would be 0. So hence we are having I naught into 0 plus omega naught, that is nothing but I naught into omega naught. And next thing is here, this is entire thing is a constant, mu into mu square ngr by 1 plus mu square, this entire thing is a constant however. So that is taken as beta. So what we would have is this entire thing is beta. So t beta is also I naught omega naught, that is t is also I naught omega naught by beta. So at any time omega is related to t by. So from this equation only, if we replace this term with beta, so beta t divided by omega I naught, so beta t divided by I naught, and omega is goes to beta t divided by I naught minus omega naught from this equation. So this is beta and t, replace with beta into t, sending this I naught this side, so beta t by I naught, and again sending this plus omega naught that side, minus omega naught, so beta t by I naught minus omega naught. So that is the thing. So omega is equals to beta t by I naught minus omega naught. So next what we need to do is integrating with respect to t. So next what we have to do is we need to integrate both side with respect to time t. So in this equation, so integration of dt on the left hand side from 0 to t. Initial time is 0, and finally by the time the cylinder comes to rest, that time is capital T. So on the right hand side also integration of 0 to t beta t by naught t, and here also integration of dt. So here if we observe, omega is nothing but d theta by dt, that is angular velocity, d theta by dt. So how much angle it has covered in given time. So dt theta by dt would get cancelled, so we would have d theta. So integration of d theta is nothing but theta. So 0 to t, just like 0 to theta. So how much angle the cylinder has rotated? Theta is nothing but how much angle. Initially it has rotated, it has not started. So after placing on the corner, how much angle it has rotated? That is nothing but theta. So upper limit integration of theta we are having upper limit minus lower limit theta minus 0, that is theta. And here integration of t dd is nothing but just like integration of x dx. So x power n plus 1 by n plus 1, that is integration of x power n dx, x power n plus 1 by n plus 1. So x power 1 plus 1 by, that is t power 1 plus 1 by 1 plus 1, t square by 2. So after applying limits, upper limit minus lower limit, so t capital T square by 2 minus 0. So capital T square by 2. Beta into I naught is taken as constant. So beta into I naught t square by 2 after application of limits. And here integration of dt is nothing but t. So upper limit minus lower limit, capital T minus 0. So omega naught t. So this is the formula for theta, and we have already know that t is nothing but capital T is nothing but I naught omega naught by beta. So replacing in that manner, so I naught omega naught by beta, and here also I naught omega naught by beta in the place of capital T. So we would have this, and if we see here, so here one I naught and here one I naught would get cancelled, and here one beta would get cancelled. So what would remain is I naught omega naught square by 2 beta would remain in this term, I naught omega naught square by 2 beta after simplification. And in this term, I naught omega minus I naught omega naught square by beta. So here I naught omega naught square beta by beta could be taken as common. Then what we would get is half minus 1. Half minus 1. So here I naught omega naught square by beta. Here also I naught omega naught square by 2 beta. So half minus 1, that is nothing but minus half. So minus I naught omega naught square by 2 beta. So minus I naught omega naught square by 2 beta. Half minus 1 is minus half. So minus half into I naught omega naught square by beta. So this is the theta. This is nothing but theta. So the number of turns rotated is, so as the angle can neglect this negative sign. So if we neglect that, so the number of turns rotated is, so finally how many turns it has rotated, how we can calculate from this is, so this is theta. So the cylinder has rotated this much angle before coming to stop, before it stops. So and for we know that for one complete rotation the angle is 2 pi. For one complete rotation the cylinder has to rotate 360 degrees, that is 2 pi. So hence if we divide theta by 2 pi, that is theta by 360. So just like if suppose the cylinder has rotated 720 degrees angle, so 720 divided by 360, so 362s are 12, so we would have that. So just like that. So 362, so that means it has rotated two rotations like that. So hence, in order to find out the number of turns it has rotated, we need to divide entire equation by 2 pi. Just like 720 divided by 360, we will get 2. That means the cylinder has rotated 2 turns in such a manner. So dividing with 2 pi on both sides of this equation, what we will get is theta by 2 pi, that is nothing but n. So here also 2 pi. So I naught omega naught square by 2 into 2 4 pi beta. 2 into 2 4 pi beta, I naught omega naught square 4 pi beta. So this is the thing we would get, and we already know that beta is this. So in the place of beta we need to replace it, and also in the place of I naught mr square by 2, because for cylinder if we consider it has a cylindrical disc like that. So every cylinder is nothing but group of circular discs put together is nothing but makes up a cylinder. So in the place of I naught we need to replace it by mr square by 2. I naught is nothing but mr square by 2. So mr square by 2. So already here 4 pi is there. 4 into 2 is nothing but 8 pi. 8 pi we would be having, and omega naught square as usual. So m, here m would be there, but from beta also we are having mgr. So already here m would be there. From beta we are having in the numerator mgr, so that in the here m would get cancelled. Here r square would be there. So here also we are having mgr, one of the r, this r. So from the beta in the denominator r and here r would get cancelled. So omega naught r, and here we can take mu as common. So 1 plus mu would remain. So here we are having 1 plus mu into 1 plus mu like that. So hence we are having mu into 1 plus mu, and g would remain the same, and 1 plus mu square would go to numerator 1 plus mu square, because we are dividing with beta in this equation. So finally we would have n. So here n is nothing but the number of turns rotated by the cylinder before coming to rest. So that formula is this. So the cylinder has rotated these many turns before coming to rest after placing in the corner. So that is the problem. So thank you.